Hey, we're recording. Very good. Now, so the idea you're going to find out, and we're dealing with in the muscular system, it's slightly different, but basically, for the future, frequency equates to amplitude. The faster you fire something, the greater the response is. It's less about the individual power. The muscle's a little bit of an. When you get to the nervous system, when you say something loud, it means you're firing it very quickly. Soft, very slowly. So frequency equals amplitude in general. Slightly different here, and that's what they talk about: graded responses, varying strength, different demands. Changes are graded by frequency. Again, I think it's the most important, and strength of stimulation. Understand that when we're talking about electromyograms, which is what the tracings are, we typically those are used therapeutically. That's why I asked you about if you're using low volt or that kind of or electrical stim treatments. They've been around forever. And typically they're things we do in the lab. We also evaluate muscle injuries looking at their electrical responses. We look for delay in the nerve signal getting to the muscle. We look at irregularities in contraction of the muscles. We used to hook up, and this is before any of the advances we have in technology, we would hook up speakers to the display. I mean, and we hear strange sounds, little pops and things like that. Look for irregular waveforms in the muscle before we really had the technology to evaluate it and understand it. So it's very interesting how it has progressed over time. I wouldn't even endeavor to talk to you about those kinds of things other than generically, uh, because I really don't know what the state of the art. I've been away for too long to be able to tell you about it. But I can give you some with me. It's background and just general information you can build upon. So single stimulus, the twitch, we do this in the laboratory, or we do this therapeutically. And all it means is it contracts and it relaxes, it contracts and it relaxes. Look, and you can see it doesn't, and effectively the relaxation occurs because here the stimulus releases the calcium, it contracts. Okay, obviously we reach the threshold response, and the calcium gets pumped back in, and now it relaxes. So it contracts and it relaxes. And if you look at the duration, what's this? Just guesstimating what 70 milliseconds. You're using a stimulus maybe one out of every 10 a second. Ample time for skeletal muscle to completely relax. That's the key. So you've reached an isolated contraction. If we summate over time temporally, okay, if we put them together, they do not have enough time to completely relax. So you're going to see, remember I said frequency equals amplitude. You're going to see a change in amplitude until we get to the physiological limit. Why? Because we're pushing more calcium out, okay, and it's going to increase the degree of, remember that ratcheting thing I kept talking about? You saw in those animations. As long as there's calcium in there, they keep pulling it. So look what happens. We have a name for this. If you draw a little line, a horizontal line here, it looks like a staircase. We call this staircasing. And so here we've got, rather than one every 10 second, rather 10 a second, we're putting effectively 20 a second. And you see this is summating over time. And this is something that's done when you have those electrical stim for rehab, or if you have in the future, not just if you're an athlete now, but going forward, this is utilized. Now, we're not done yet. We'll increase the muscle tension to a near maximum, produces a smooth continuous traction that's summate. So further increases in stimulus frequency cause muscle to progress till it's maximally contracted, but it continues, it undergoes a kind of quivering, and they refuse it in unfused tetanus. They name the disease for what it does: causes your muscles into a spasm that can't break. Tetany. So we figure this is tetanus. Voila. Once we get to the maximum level and it's unfused, now we're doing 30 of those a second roughly. You get this, it's really at its maximum, but it's not sustained in one, horizontal linear form. But you can see how rapidly those stimuli are coming at you. And yes, we could achieve fused tetanus, further increasing it. Let's say now we're up to 50 of these a second. Complete tetanus, contractions fuse into a sustained plateau, and that will lead to muscle fatigue. We use this extensively. Maybe you who are athletes have had this done, and they have spasms that they can't break. That's what we would do in physical therapy. We would set it up to take it up to tetany and hold it there. And over time, you do a variety of treatments. You'd hold it at maximum contraction X amount of times over X amount of treatments. Maybe you had X amount of minutes or X amount of seconds. And then you have the person come down not once, but 2 or 3 times a day into physical therapy in the hospital, or have them as an outpatient, schedule them accordingly, if you could, to try to break the spasm. It was a very useful alternative to excessive amounts of. We dealt with an indigent population. We dealt with a homeless population. We dealt with alcohol and drug addicted patients. You wanted to stay away from painkillers and controlled substances because they weren't going to use them unless it's what they wanted to use. They'd sell them to get what they wanted. Very different. You have to understand the population you're dealing with clinically. It's not what they're going to be doing with you folks here in the athletic department would be totally different. Okay? An approach like that. So we used to use that. We'd bring up the frequency. We called it surge. You're trying to re-educate the muscle. You're trying to strengthen the muscle. When you held it up to tetany, you're trying to fatigue the muscle and break the spasm. A lot of times we'd have pads on either side to try to get the joint moving again. So if you couldn't contract it, we could contract it for you a little, and then more and more and more. So I have the orthopedic group I work with. Before I got there, they were considered the best in Philadelphia. They ruled literally. They were, but in each treatment room in their office in South Philly had one of these units. That was SOP for them working with their patients. Here it is, fused tetanus. So you can see how many you're getting. This is maybe 10. Maybe you're getting 100 of these, but 50 or more, you're going to lead to the fusion. Be aware of that. So effectively, if we increase the strength, there's a limit. We can only make the amount of fibers that contract that are available to us in that particular motor unit. So the stimulus is sent to more muscle fibers, leading to more precise control. So threshold, we don't reach threshold, nothing happens. If we reach threshold, we'll have an observable contraction. But if we maximally stimulate it, we're going to recruit or bring into play all of the motor units. And you can see, so here, didn't get to threshold. Aha! So you can see nothing. Now we're getting a couple tiny amounts of action. As we increased, and that's why it's a little different than nerves, that has nothing to do with the amplitude of the stimulus. Once we got to maximum stimulus, effectively we have recruited all of those. Once we get all of them recruited, there are no more. So you can increase the stimulus above maximum. It's not making any difference in the amount of contraction. So there's a physiological limit. So that's not subtle. That's a distinctive difference between nerves and muscle. And let's see it when we get to nerves as well. So, and then other things that are involved with the size. Okay, smallest muscle fibers first, larger as it increases, largest only for the most powerful. So, and the idea of this, there is the asynchronous nature, the way your body does it. Others rest while others contract. So we're able to sustain physical activity, whatever the physical activity, whether it's athletic in competitive sport or just everyday activities. And you can do them because you'll be using different units at different times that are there. And they're just showing you how, small as, you get that. Goldilocks, bears, right? Too hot, too cold, just right. I love that. Do you remember that, the Goldilocks story? Home invasion. She trashed the place goes into the bear's house, eats their food, breaks their furniture, sleeps in their bed. What would you call it? Wouldn't you call it a home invasion? I would. And we're celebrating this. The same thing. Would your mom let you live in the woods with 7 little people? Maybe. My daughter, no. But she might do it on her own. Yet we celebrate that. Yeah, Snow White and the 7 little people, because we want to be politically correct. She hasn't heard that routine. I'm doing it for the newbies. Did you get the routine? Good. Or sleeping around beauty. Pardon me if I'm being politically incorrect, but somebody has to. Trying to think of a bad one with a guy. Oh, there's got to be a bunch of those. But they always had female lead characters. I'll get there. So constant, slightly contracted state of all muscles. It's your muscle tone. We do this all the time. Again, my concept is use it or lose it. So we're constantly have tone. You have to take this into account. Okay, from a medical or particularly a surgical field. When you put somebody to sleep, their muscle tone disappears. You have to know what it's like. We would shorten and lengthen tendons. So imagine, I mean, if you do it incorrectly, it looks good. When they wake up, all of a sudden they got a finger that's down here or a toe that's up here, and you can't get put back down. You can over shorten or over lengthen. That means you're going to have to go back in and do an additional procedure. It looks pretty bad. So you have to always take this in. And so spinal reflexes, stretch receptors, firm, healthy, ready to respond. And again, isotonic muscle changes length to move loads, and they can in either direction. You can, if you're flexing the muscle, we call that concentric. If you're still utilizing the muscle, if I'm lifting this up, concentric. If I'm putting it down, eccentric or eccentric. So remember the distinction between concentric and eccentric. We use muscles in different ways. We can strategically shorten or strategically lengthen. Not much here, not much here. And again, electrochemical and mechanical events are the same. The difference is, are they shortening? Okay. Isometric contractions, they talk about like spinning your wheels or something like that. But that's been a valuable form of exercise when people did not have. Do you do those, you guys who are in sport? Do they do isometrics where yeah. I mean, we have at a university, you have these days, I'm sure, an abundance of equipment. But I mean, if you dealt with small, you had to work with those types of things that were there to try to live. I mean, you're pushing against walls and doing all that type of stuff, so you would be able to exercise with limited apparatus that people don't have. I mean, it's a big change. Now the abundance of places for workout, not just people who are in scholastic athletics, but people, everyday people. I mean, people go to the gym all the time. It's just crazy how it changed to the good, certainly. So I've got a lecture last night about why I should be there more frequently in very simple terms that I will not repeat. So energy. Last part about this particular PowerPoint is energetics. And we're pretty well rapidly getting through this. So if it's not done today, it'll be done easily enough on Wednesday. So you get the idea. We're moving along. Energy for contraction. We know about ATP. The difference is you and I and most of our activities do what's called anaerobic bursts. We do it anaerobically. Most sport is anaerobic. Aerobics are rare, comparatively speaking. And think of the activities you do, whether you're getting up, whether you take a quick walk to the restroom, you forgot something in your car, up in your dorm room. That's not aerobic. They're short burst activities. ATP supplies the energy needed for the muscle fiber we know about this, move and detach, pump the sarcoidotic reticulum, sodium, potassium pumps. We deplete that in 4 to 6 seconds. Most of what you're sitting here doing, one activity, moving your, whatever it is, moving your fingers to work on that, looking at your phone, whatever, however you're doing, I don't care. Most of those activities, 4 to 6 seconds, is a ton of time. So it's the only source for contractile activity, therefore it must be regenerated quickly. 3 methods after using up the available. So if you're running after something because it's important, you left it in your car or whatever, 4 to 6 seconds, all the energy you got. Where am I getting it next? That's where you get direct phosphorylation of ADP by the creatine phosphate. The only thing that makes ADP and ATP unique is high energy bonds, right? So how do we generate energy? We pop off an ATP, an inorganic phosphate off of ATP, and they separate relatively quickly, and boom, we have energy available to do work. We still have the ADP if we can transfer it from another high energy bond, and that's where creatine phosphate comes in. There's a certain amount of good news and bad news with this. It's very limited. It's not a mistake. That was the misconception. Oh, I'm taking creatine powder every day. I'm going to have more energy. The reality is what you all know by now, how proteins are metabolized. You eat proteins, they're broken up into amino acids. Effectively, they're building blocks. We use them for a variety of things. If you eat more building blocks, okay, and you exercise with an appropriate program, you can make more muscle. It's not like it's magically going to go into muscle. Any protein that you eat, if you have a protein drink, there's so many different supplements today. Whatever's in there, they only work if you're on a program to use it appropriately. And the big problem, everybody, is you have to make sure your kidneys work, and you drink the appropriate amount of fluid to wash it out, because we have a very limited tolerance of nitrogen. Now, all those amino acids, what do they have in common? Nitrogen. So be very careful with it. If you go on whether it's a weight gain or a weight loss diet, be very aware of the role that your kidneys play. You're young and healthy, your kidneys should do very well. So it's hydrate with regard to that. Which I do not do enough of. That's always been. I don't drink a lot of liquid when I'm in class. So the next thing you're already familiar with, glycolysis. At that point, we're using those muscles so aggressively, the oxygen stored in myoglobin is gone. The glycogen is gone. So we have limited resources. Whatever's left usable with some limited amounts of glycogen for sure, effectively that muscle's contracted. The blood vessels can't produce more oxygen availability. We go into anaerobic glycolysis. 2 ATPs. You all know glycolysis. Okay? And by that time, you're going to see the amount of times that are available. It's not much, in less than a minute. Depending on how well conditioned you are, 45 seconds to a minute. If you don't convert to the aerobic pathway, you're going to have to stop. And that's what aerobics are all about. Direct phosphorylation of ADP by creatine phosphate, unique, high energy phosphate, enzyme involved, have enough ATP and creatine phosphate reserves. So the first 15 seconds, you're using up all the energy. Effectively ATP or ATP-like energy. And it's just a simple transfer with the release of ADP, or with the ATP, and the release of the inorganic phosphate, rather. Very limited duration. At that point, glycolysis and lactic acid. Why lactic acid? How do we get rid of lactic acid usually? Why lactic acid? This is called wait time. It's an educational site. You throw the question out, you give everybody a chance to answer. In glycolysis, in the absence of oxygen. In the presence of oxygen, it can enter the mitochondria. And then we can go through, whatever cycle you want to call it. Citric acid cycle, Krebs cycle, tricarboxylic acid cycle. Doesn't matter. What happens is in glycolysis, we have those unpaired electrons. We have to find a parking place. The substrate, okay, is pyruvic acid. And when you add those extra electrons and the appropriate hydrogen with them to pyruvic acid, you get, that's right, lactic acid. That would be something I would think would be relevant. I won't ask you that question. I would have thought that would have been relevant previously. Those are the little things you should remember, depending on where you're going. So low oxygen levels prevent pyruvic acid from entering. We know that. Krebs cycle, if you want to just simplify it, enters the mitochondria, blah, 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 bulging muscles, impaired oxygen delivery, anaerobic glycolysis, and we end up with lactic acid. Lactic acid is not necessarily the player that makes you stop. It plays a role, but we can utilize it in the bloodstream for a variety of purposes. The real thing that causes those muscles to cramp up, tighten, and you just go, I can't do this anymore, is really electrolytes. The waste products are more chemical waste products, but not the acidity per se, as you will see. If lactic acid gets into the bloodstream, it can fuel other systems. And in the liver, once we have oxygen available, it'll convert it back to pyruvic acid and effectively, you remember that thing, the opposite of glycolysis? What's that cycle? Glycolysis this way, what do we turn it is? Gluconeogenesis. She loves that. That's like her favorite cycle. And we know the she to whom I'm referring. I like sitting on those lectures. I learned stuff today on our MCAT little soiree and get together. All those C's and N's. That was a good session. It really was. I was very pleased. Anaerobic respiration yields only 5%. As much ATP as aerobic respiration produces ATP 2.5 times faster. So it's quicker, but much less efficient. So there's a certain balance, but there's a limitation. So 30 to 40 seconds. At this point, 45 seconds to maybe less than a minute that we have energy capability. So we have to flip over to aerobic. The whole idea of aerobics, what is it? Using big muscles and marrying your breathing, because that's your oxygen coming in and your carbon dioxide waste product going out. You'll perspire away the water. And that's what happens in aerobic exercise, which we can do. Even somebody like me who's comparatively not anywhere near as good shape as you guys, I can still get on the treadmill and go, at a moderate speed and a moderate degree of elevation and do 3-4 miles beyond that for an hour and really not get tired, as out of shape as I am, to be delicate. Why would I do it? Why would I want to do that? Why would I want to go to the gym? Yeah. Perspiration, people sweating. Okay, I like the outfits on some of the people who are there. I'm not going to lie. And I like the girls too. See, you got that. That was clever, wasn't it? I know I'm being politically incorrect with regards to, but you get the idea. Why do people do that? Why am I surrounded by a bunch of old folks on the Silver Sneakers program at some clubs? Why would we use it? Why would they encourage you to do aerobic activity? See, you're not old. You haven't thought about that. You're a proverbial ticker. Cardiovascular. Your cardio, at my age, very first thing I do. It's the wrong order to do that. You're supposed to do your cardio at the end. No, thank you. I might be ready to leave at the end. I could think of a reason. So I'm going to do 30 to 40 minutes of moderate to relatively intense physical activity, get my heart rate up to my target level, okay, with roughly 115 to 120, and hold it there for 30 to 40 minutes. And if I do that 3-5 times a week, hopefully I'll be here concurrently, to teach this. I was just talking to Dr. Rob. He said, how much longer do you think you'll be here? I said, you mean here teaching or otherwise? Exactly what I said. So 95% of our ATP during rest and light to moderate exercise, slower than the anaerobic pathway. We all know chemical reactions in the mitochondria, large amounts of ATP. I'm not going to ask you how many ATPs and all that stuff. Fuels used include glucose from glycogen, we use initially, blood-borne glucose, and then that good thing, free fatty acids, which helps me keep my girlish figure. Anybody? One freaking laugh. Thank you, Abby, for contributing today. I appreciate it. So that's when the difference between what you go into after the cardio part, you go into a fat burn. And for somebody like me, who I'm a sugar addict, I'm Sugar Addicts Anonymous. Hi, I've been addicted for how long? Hi, Lou. I'm in a 12-step program, starting with eating more candy. Moving on. So the whole idea is to be able to understand that and what type of sports you're doing, what we have to work. And that's why I wouldn't endeavor to teach it to you. Length of time the muscles contract using aerobic pathways for hours. Anaerobic threshold, a threshold, the point at which the muscle metabolism has to convert. Okay, and they show you that graphic. The physiological inability to continue contraction, ionic imbalances, potassium, sodium, calcium, disrupting membrane. We get back to the membrane potential. How can we contract if we can't generate the appropriate threshold and action potentials without irregularity? The inorganic phosphate interferes with calcium release from the sarcoplasmic. So there's reasons behind this. And more. Decreased ATP and increased magnesium levels can interfere with voltage-sensitive T tubules, decreased glycogen. It's not so much lack of ATP, it's these other factors that I'm talking about. And again, the lactic acid will reach a threshold where it has to be dealt with. And this, they have a fancy name for it. They call it excess post-exercise oxygen consumption. Maybe you have, I call it an oxygen debt. And you and I use the same term, I hope, called catching your breath. It's basically what you do. Oxygen debt is an acceptable term to me. I don't use this EPOC acronym. Maybe you need to use that depending on where you're going, whatever the appropriate term is. Hopefully they tell you. Oxygen reserve, and we replenish it. We get back our oxygen, we convert the lactic acid, we replace the glycogen, which was overused. Remember, you only can store it in liver and skeletal muscle, and we replace the reserves of ATP and creatine phosphate. That's it. Please be familiar with all of that. I thought that was going to be complicated. So. I know I'm good. I can keep recording. Just wanted to get rid of that PowerPoint. Additional factors. Things that I think are we recruit more when we want to generate greater force. The bulkier the muscle, the stronger it is. And again, we can't make more muscle cells, more fibers. Okay. There is some research going on into replication of muscles. I really don't think at this point, we could say that there is a regenerative capability, but most importantly, so in the old days, we used to say they can't undergo hyperplasia. We can't make more, but we can hypertrophy, make them bigger and stronger. And if we don't use them, they atrophy. They get weaker and smaller. So that's really important. And we obviously, the frequency and the force. And to me, this is the one that is not inherently obvious. And you should be aware of this 80 to 120 rule. If the sarcomere is less than 80% resting length, it's already overlapped too much. Well, what's force? You all had physics. Right? Mass times acceleration. The acceleration is based on the number of available myosin heads and active sites on the actin. If you already use them, you can't generate mass times acceleration. You can't change the length rapidly enough. On the other hand, If you have already stretched it out, it's very hard to rapidly get attachment to those available myosin heads. You'll see it graphically. And so it's not frequency we get, larger we get, okay, more recruitment we get, but the length is better demonstrated this way. Normal resting. See what happens. We're under the 80. We're at 75% more or less. We've already got it mostly. We have very limited length to get the contraction, and here we can't get enough purchase rapidly enough. That's really overly stretched. So you want to be in that golden zone between 80 and 120. If you're up like this, can't do it. If it's way like this, you can't do it. So it has to be the right area within 20% of its normal resting length. That's what that 80 to 120 rule is. And everything else based on the different kinds of fibers. This is important too. We have slower, fast fibers. It was a little bit into why the gastrocnemius in the calf versus the soleus, the gastrocnemius, medial and lateral head, are power muscles. The soleus is more of a postural muscle. It has to do with the different kinds of fibers that are there. So we have oxidative and glycolytic fibers. As you will see, oxidative utilize air, glycolytic do not. So you have slow and fast oxidative fibers, and glycolytic fibers are fast. Most muscles have a mixture of them. Okay, all fibers in a motor unit are the same, and it's about genetics. I tell everybody about my vertical jump of a half an inch at best. I don't have those.
You should try it.
Yeah, God bless you. I love sports. I'm just not great at them. I've taken sports that don't require a lot of physical prowess or athletic ability. Like in football, they always put me in the middle of the line. Sorry. Hey, it's okay. Trust me, when they chose teams, I was last. My annoying aging now, God bless him, brother-in-law, my sister's husband. Remember, I told you how long they'll be married. We're approaching. We're getting there. We're pushing 60. 58 years coming up in May. It's a good run. First guy they picked. Pick a sport. Pick a sport. It's awful. Great dancer, could play musical instruments, handsome guy. Oh my God. Boy, did I get the short end of the stick. It's okay. And worse, he's an attorney. So, muscle fiber type, slow oxidative endurance, postural muscles, fast oxidative, that's where those gastrocnemius muscles come in. Fast glycolytics, very interesting because they accelerate so rapidly. And so there's a mixture of those. And again, that's why certain people are extraordinarily athletic. When we start talking about multi-sport athletes, very interesting. Very interesting. I mean, the best basketball player ever that I saw, and I'll open the debate to LeBron and Michael Jordan. I mean, he could only play minor league baseball. Deion Sanders played Major League Baseball. Bo Jackson was an all-star in both. Bo Jackson was the all-star MVP in baseball. Some people, it's God's gift. And so that's it. And again, if we don't have a lot of load, if this is light, we can contract versus greater load. Not a significant feature, I don't think. The whole idea of aerobic or endurance activities, jogging, swimming, biking, lead to muscles and capillaries. We need to numb capillaries within muscle, increase mitochondria, increase myoglobin, greater endurance, strength, and resistance to fatigue, converting those fibers into oxidative fibers. When you're doing that in the heart, it's extraordinarily significant. It's all about this. You build additional blood supply to areas that have limited blood supply or blood supply that exists as compromised. That's why it's so darn important. But not for you. It's the type of thing that really is important for people in your orbit who don't. I mean, it's just, it's not at all. I mean, my mom lived to be 93, and I'm sure she never exercised. And for, oh, I don't know, 30 years, smoked 3 packs of cigarettes a day. Go figure. Genetics play a role. And I favor my mom's size. But she stopped smoking because my dad nagged her to death after he stopped in 1967. She died in 2011. So a lot of this. So when we do, I don't know what you do today, resistance, progressive resistance exercises, when you want to strengthen, you do that. You don't, it's all about the number of reps. You do the number of reps, you do the frequency that you do the reps the same way. You gradually increase resistance. Whether you're doing straight leg raises for knee problems, maybe you have weights on them, you have Velcro weights. You could take, you could make your own weight by having a jar or something like that and putting it in a bag and the bag on the end of your leg. Doesn't matter. But every couple of weeks, you gradually increase the weights for a normal person. How they do it for more advanced sport, I don't know. That's the difference. So we're progressively increasing the resistance. On the other hand, when you're doing endurance exercises, it's about range of motion. So you can increase the amount of times you do it, frequency you do it, but you don't increase the resistance. So there's a difference. So resistance exercises, PREs we used to call them, and maybe there's a state of the art now. I do not know. So atrophy of disuse is something for young folks like you might see being in an immobilizer or a cast. That's why we see less casts and more of those types of things that we can take off. Removable slip flints, removable casts, more advanced technology. So if there's an injury, you can do skin and wound care if necessary, and they can do active physical therapy. So it's really a remarkable thing. So immobilization, so and young people, they tend to come back very, very quickly. But the problem is atrophy of disuse. If it's not used and rehabilitated appropriately, that lost muscle tissue is going to change over into fibrous connective tissue, and then it's not rehabilitatable. So that, depending on the fields that you may or may not be going into, be aware of that. And when people, again, if you're not going to medical or clinical field, and somebody in your orbit, it wouldn't help to find out what their treatment is. It's hard to, with family members, but I'm specifically to be aware that they're doing things properly. The last piece that I'll introduce today, without getting too much into that, is what really what we look at in advanced physiology more than anything else. We look at smooth muscles, muscles that are involuntary. We're a series of hollow tubes: respiratory, circulatory, digestive, genitourinary. Tubes, tubes, tubes. And what do those tubes have in common? Smooth muscle. So all of those things, until we get into the capillary level, effectively, they all have smooth muscle, and it's how it's arranged. And we're not talking about cardiac. We'll get back to that when we do the heart unit. Most smooth muscles are organized in sheets that are tightly packed, and we're going to see it again and again. Digestive is really the poster child for this. 2 layers, circular and longitudinal. Around the tube, the lumen, the hollow area. First circular and then exterior to that longitudinal, because that's what makes peristaltic action. Okay? We basically squeeze and push, squeeze and push. That's the beauty of this arrangement. Circular fibers around the circumference, contraction, the lumen of the organ, in this case the hollow tube, to constrict. Longitudinal fibers will cause it to shorten. They push it along. That's how your digestion works, peristaltic. In female reproductive, when we're looking at fertilization and the sperm has been ejaculated in, we have reverse peristalsis to push this, to effectively assist the sperm on their journey toward fertilization. So we see this consistently. That peristaltic action moves urine. When there's a constriction, such as a urinary stone, it goes into colic, reflex spasms that hurt like hell. So alternative contraction and relaxation of the layers mix and squeeze substances through the lumen of those hollow organs. They are spindle shaped, meaning they're narrow at the ends, wide in the middle. Thin and short compared with skeletal muscle, which are wider and longer. One nucleus, no, and I would underline visible striations. Lacks the connective tissue sheaths other than endomysium. So you're not dealing with epimysium, perimysium. We're not looking at that elaborate pattern you saw with skeletal muscle. And you're going to see that. There's the differences. You're going to see we don't even have nerve fibers. We don't have a motor end plate. We have something called varicosities. Varicosities aren't only found in blood and veins, okay? In this case, bulbous swellings, which is what a varicosity means, nerve fibers instead of neuromuscular junctions. And they release neurotransmitters into what they call a diffuse junction. There's no motor end plate need apply. And you're going to see they're autonomically involved. I will leave it there. We will start there because after this chapter, we do the nervous system and then we do the autonomic nervous system. So we're starting to put this physiological package together. In lab, I want to get started with eye and ear pretty rapid, pretty aggressively, because I like to do eye and ear and cardio in the lab. Okay. Thank you very much. See you all Friday. For those that are here,